we are solving quadratic equations. No, isn't it part 2? Yeah, it's part 2. I think there's a typo. So it's day 2. Okay. All right. So yesterday we solved quadratic equations by factoring. Okay. Today, what are we using? What is this? The quadratic formula. Miss Sly, can't I just do everything with the quadratic formula? Nope. The quadratic formula does not encourage thinking. Sometimes it's necessary, but if you can factor it, that's better thinking. So today's goal is to solve quadratics using the quadratic formula. But then there is some thinking today, because today, new word alert, discriminant. Might not be a fully new word, but we're going to use something called the discriminant to predict how many solutions we're going to have. Is it going to be too complex? Is it going to be too real? Is it going to be too real but identical? Right? So the discriminant helps us figure that out. All right. So in grade 10, we had this fun formula called the quadratic formula. Now, it's not an equation, it's a formula. A formula is something that you plug numbers in, right? So let's do a few examples to remind ourselves how to solve quadratic formulas. All right. So in example 1, we've got solve 2x squared plus 5x minus 150 using the quadratic formula. Now notice, if I have this equation, am I finding x-intercepts and zeros or roots and solutions?
Roots and solutions.
Why?
Because it's equal to 0, so it's an equation and not a
close giving. Yeah! Round of applause. All right. It's a function if there's a y and an x in the equation. That means you can graph it. So if you can't graph it, you can't find the x-intercepts. And the zeros is just another word for the x-intercept. All right, so we are just finding roots. And it says roots should be kept in fractions if that applies. So let's write out this equation. Notice, it equals to 0. You cannot use the quadratic formula if it's not set to equal to 0. And now let's hope we remember that the coefficient of x squared is a, the coefficient of x is b, and what do we call a number that doesn't have a variable? It starts with a c. Okay, a number that doesn't have a variable is called a constant. You were going to say it? Oh, you would have gotten points. Because that value never changes. All right, so we've got our a, b, and c. Now we write out, now actually we might need to, so we don't switch anything. So a is 2, b is 5, and c is 150, negative 150. Okay, let's write out the formula. X equals minus b plus or minus. I will always give this to you, but it is helpful to memorize it. And you might find as you do your homework, you just end up memorizing it, right? You will do it so many times that you will just memorize it. All right, so let's plug in our numbers. X equals minus 5 plus or minus b squared. So 5 squared. Now, to be safe, you can always use brackets, right? Because if there's a negative number in there, you're going to mess up without brackets. Minus 4 times a times c. Now, before you do it, I want you to pause and use your critical thinking. And the question is, will the number under the square root sign be positive or negative? Don't try it, predict. Show me with your fingers, is it negative or positive? Good. So what we're seeing is this. If you didn't get that, watch here. I've got negative 4 times negative 150. That means this part will be positive, right? So, and anything squared is always positive. So it's like I'm adding two positive numbers. All right, so let's see where I got. Plus or minus 25. Negative 4 times 150 is, I think, 600 times 2 is 1250. Right? You might want to have your calculator out. 2 times 2 is 4. Oh, wait, Miss Sly, you made a mistake. Yeah, you say 1200. I feel like this is 1225 is the square root of it 25?
35.
35? Interesting. Okay, but we're not done here. Because we don't have a radical, we can add the 35 and the 5, right? So x1 is going to be the version 5 plus 35 over 4. So that's 30 over 4, and I can reduce that 15 over 2. So x1 is 15 over 2. And as the question said, leave it in fraction form. Do not write 7.5. Okay, x2. Negative 5. Now we did the plus, so we write minus 35 over 4. Negative 5, negative 35. Well, that's negative 40 over 4, and that equals to negative 10. So x2 in this case is negative 10. Could we graph that if this was a 0? Yeah, right? Two real numbers. But these are not x-intercepts. They are just roots. Question? Yeah.
What's the difference between a root and an x-intercept again?
Okay. The x-intercept is on a graph. It's where the parabola touches the x-axis. Okay. That can only happen when you have a function, something that has a y and an x. If you have an equation, i.e., there's only x's, then you can only find the root or the solution. All right, let's try the next one. So in this case, folks, you can sort of be working ahead, right? We're like, okay, our A is 4, our B is negative 20, and our C is 25. I probably won't take marks. I won't take marks off, but really good math communication includes stating the quadratic formula each time. So x equals minus b plus or minus b squared minus 4ac over 2a. And then I sub in my numbers. Uh-oh. Negative 20. What does that give me? Ooh, good job. Ooh, another situation. If I don't write negative 20 in brackets, I might get the wrong answer. Anyone have concerns right now? I have a concern. Really?
This graph is pretty chill so far.
What's the concern, folks? What are we noticing? Look inside the square root bracket. Will it be positive, negative, or we're not sure? This is what I'm, yeah, Mustafa?
I think like it's going to be negative, but then the whole thing would be zero.
So this is what Mustafa's noticing. Oh, look, negative times positive times positive. What is that? Negative. Okay, I wonder what that means. So if this is bigger than this, we get a negative number. Ooh, interesting. Let's see where that takes us.
I think it's going to be zero.
Okay, so negative 20 squared, 400. Okay, so 4 times 25 is 100 times 4. Aha. Interesting. What's the square root of 0? Oh my goodness. 220 over 8. Right? We must, if you have a fraction, you must simplify it. Right? This is where you lose communication marks. Yes, Mustafa, what is the burning question?
Do you have to do like 2, like x1 is equal to 5 over 2, and then x2 would be equal to 5 over 2, or just?
Like you're saying x1 and x2? Well, but what is x1 and x2? What kind of situation do we have here, folks? Miles?
You have 2 real roots, but they're identical. So
2 identical real. No, they're not distinct.
What is distinct?
Distinct means different. So what does that tell me about the parabola? If you have 2 identical roots, yeah?
The vertex is on the x-axis.
Okay, and is the parabola upside down or right way up?
Right way up.
How do you know that?
Because there's no negative in front of that a.
Because A is positive. So I just want to kind of draw it out. Okay, so that means my parabola is going to open up and it's going to be something like this. If this was a parabola, it's not. It's a quadratic equation. But just so I can kind of visualize what this means, right? Now, in this case, we have roots, not zeros. Yeah.
Would you take off marks if we would write x1 and x2?
You could do this. x1, comma, x2 is 5 over 2. Because there are 2 roots, right? It's just that they're identical. Great. Okay, let's try another one. Okay, watch this. Because this equation does not equal to 0, we must move the negative 1 to the right side. Once we have done that, this equation is in standard form and we can use the quadratic equation. The quadratic formula. Okay. So A equals 5, B equals 5, C equals 1. All right, so we're solving away. B squared is going to be... Some of you might want to skip this step where you write 5 squared. You're like, well, that's just 25. Bless ya. Gesundheit. 2A, 5. Okay, so we got 25. Okay. Okay, so it's not a complex root, but it's got a radical. That's kind of ugly. Yeah.
What does complex refer?
Complex would mean there's a negative inside the radical sign. And that's okay. Here, we can say, okay, x1 is -5 plus, right? I don't care when you use the plus or minus, over 10. x2, now we have to use the minus. Oh, there's a mistake just begging me to make it, isn't it? What is it, Lily? Oh, the mistake is so there. It's like, please, Miss Slide, just make the mistake. What is it, Luke? Right? Oh, can't we just simplify and divide everything by 5? Come on. Can't I just go -1 plus √1 over 2? Can I? I cannot. Because this is in a root. Okay? You could say, okay, I'll write it like this. -1 over 2 minus √5 over 10. You could. Not necessary. Okay. All right. So in this case, how many roots? 2. Are they real or complex? Real. And are they identical or distinct? Good. They're different. They're distinct. So let's write that down. 2 real and distinct roots, meaning they're not the same. What do you think the next one will be? Just take a wild guess. Come on, what have we not done yet? We have not done complex roots. Aren't we excited? Yeah. All right. Okay. Solve an equation. State only the simplified exact roots. Do you know what exact tells you? It means don't take the square root or leave in radical form. Leave in radical form, right? No decimals. That's not an exact answer. Okay, so I like that this question is already in standard form. I can immediately take the A, B's, and C's, right? So my A, what's my A? Yeah. B is -2 and C is 3. Great. Okay, so please try not to copy what I'm doing at this point. I do see your phone. Please put it away. Right? Ooh, some news. Excellent. Okay, -2. What is it? +2. Good. So if you want to do that quickly, you can. Is that a question, Sophie?
No, I just got it wrong.
Which one?
Like that one that we're doing, I just realized that I got like a positive root, so I don't know what I did.
Bring it to me after class.
No, yeah, just
Yeah, but bring it to me after class. We can look at it.
okay.
All right. So we got -2. Well, negative is positive, right? So you can shortcut that. B squared. Okay, it's a negative. -4 times 1 times 3. Uh-oh, look at that again. Negative times positive times positive. Uh-oh, what does that mean? What's it going to be, folks? What's it going to be inside the square root? No! On a Tuesday morning? Come on, it's Taco Tuesday. You can't do that to us. Okay, 2 plus or minus. We've got 4 minus 12 over 2. I can deal with this. I can do this. I believe in myself. Okay, square root of -8. over 2. Okay, now you might have the question, can I simplify? I would actually wait because it will clear up. Okay, let's write -8 in a simplified form. So on the side, let's do some fun work. -8 can also be written as, are there any perfect squares in there? Which is it? 4 times 2 times -1, right? We break it down all those 3 because the square root of 4 is a 2. The square root of 2 cannot be simplified. And what's the square root of -1? Ooh, how fun. Is it fun? Okay, so square root of -1 equals I. That's what we did yesterday in the lesson, right? So as soon as you have a negative under your square root, you're like, ding, 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 ding. It's not about you, it's about I. Yeah, that was a good one. All right, so let's simplify it. We've got 2 plus or minus 2 root 2I over 2. Go ahead and ask that question.
Can you cancel it out?
Can we?
I think so.
Can we cross out the 2's?
I guess.
Why? Marley,
Only God knows.
you just know. You're like, yeah. Yeah, because watch this. This 2 is not under the radical sign,
Yes.
right? So yeah, we can divide. Basically, we're reducing a fraction. Or if you want, you can say, okay, I'll factor the top 1 plus or minus 2I. Right? That's another way of looking at it. If you factor out the 2 from the numerator, then you can cancel out. So we've got 1 plus or minus root 2I. Yeah? Yeah? Questions? Okay. So we've got x1 is 1 plus root 2I, and x2 is 1 minus root 2I. And in this case, how many? How many roots? 2. Are they real or complex? Complex. Are they identical or distinct? Good. Now, without really telling you, I've actually fast forwarded us in the lesson. I've already done the next part with you. The discriminant is what happens under the square root sign. And we've already been predicting, right? We've been looking at the discriminant without really knowing that we're looking at the discriminant. I hope you don't feel like I manipulated you here. I know. You're making us do math before we're ready for it? Yes. All right, so watch this. The discriminant is a part of the quadratic formula. It is this part. Whoa. That. The discriminant is b squared minus 4ac. Write that down. And so when I've been saying, oh my gosh, what's happening under the square root? If we have a negative, what's that mean? Right? This is how we can figure out the types of roots. So you can predict what kind of roots you'll be getting. Okay, so if I have the discriminant, b squared minus 4ac, be positive, right? So if everything under the square root sign is positive, what does that tell me? What kind of roots or root will I have? How many? 2. Real or complex? Why not complex?
Because it's not a negative under the square root.
Okay, that's this case. And are they identical or distinct? So let's think. if I have an actual number, it's like I'd go 2 plus or minus root 25. Will I have two different ones or one identical?
Two different.
I will have two different ones because I'm going to have 2 plus 5, 2 minus 5. So real and distinct roots. Okay, now we have that case that we had. Remember, we had 400 minus 400, and that got us to the square root of 0. Which example was that? Let's go back and look. Oh, it was example 2. Well, how many roots did we have there? Well, let's be real. We still had 2. Okay, were they real or complex? Real. Distinct or identical? Identical, right? Team Wood had that great question. Well, can I just write x1 and x2? Absolutely, because what you're saying is I know they're 2 roots, and I also know they're identical. So if you do the discriminant and you get it equal to 0, that means we have 2 real identical roots. And then there's that horrible case where you get a discriminant that is negative, where you get a negative number under a square root sign, and you're like, oh yeah, that's I, right? And so when we have I involved, how many roots will we have?
Two.
Always 2, right? Will they be real or complex?
Complex.
Will they be identical or distinct? Always distinct, never identical. So there's only one situation where the roots will be identical, and that's when the discriminant equals to 0, right? Let's just remind ourselves, this little piece of a formula is called the discriminant, right? Discrimination is like putting things in groups. Well, here we're discriminating, right? All right, so let's do 2 examples where we are predicting. I don't want the roots. Yes.
Would I be considered an imaginary number?
Yes. So you can say complex, or you can say imaginary roots. Those 2 are equivalent.
Because would real roots also fall under complex numbers?
Real is not complex. Complex is only imaginary.
Oh, okay.
Yep. All right. So in this question, is it asking us to find the roots? Determine the number and type of x-intercepts for this function. Do we need to find the x-intercepts? No. They just want to know how many. And who can tell me why it is that in this question we're asked about the x-intercept and not the roots? What do we see in that equation? What is it, Sophie? Exactly. So the y tells us, oh, this is a function. And a function has zeros and x-intercepts, right? I know for me, a non-word person, this would be confusing and I would need to make some notes for myself. Okay, so all we have to do to figure out the type of roots is take the discriminant. Isn't that wonderful? We don't have to do the rest of it. Is that a fire alarm?
It's been a long one.
Pardon? Oh. All right. What is B? C minus 5A 1. All right. So let's see. So B squared is 9 squared minus 4 times A, and C is minus 5. Okay. So 9 squared. Does everyone know what 9 squared is? Just good. If you don't, Like actually get the cue cards, like the to practice your multiplication skills. Okay, negative 4 times 1 times negative 5, positive 20. And so our discriminant is 101. Is it positive, negative, or 0? Yeah. So since it's positive, what kind of roots are there? Give it a shot, Luke.
2 real and 2 real distinct.
Beautiful. Therefore, 2 real and distinct roots. Okay. Let's try the next one. Ooh, Miss Sly, what do we do in this case? Where did the B go? What's the B? It is 0. Okay. Zero squared. That's interesting. Minus 4 times 1. Oh, gosh. Oh, no. No. A negative number. I know. I want to cry. What's that mean? It does not mean that okay. It means how many roots?
2.
God, folks, it's always 2 roots. Okay, real or complex? Ah, the negative discriminant tells me I have complex roots. And when they are complex, can they ever be identical? Never. So if you have complex roots, they're also always going to be distinct. Oh, wait. Is it roots or x-intercepts? What are they? What are they? They're x-intercepts, yeah. I will say you won't get it wrong to say roots. I like the word zeros. Was that a Y?
It says that, like, at the top there's a Y, so why is it?
Exactly. Distinct zeros. Okay. Can I boggle your brain?
It's like, so if we will write roots, it will be a mistake, yeah?
No, this is what I'm going to tell you. This is an equation, agreed? Well, folks, I have some confusing news. That is also an equation, right? It has an equal sign and it has things on both sides. But in addition to being an equation, it's a subcategory.
So 3x up to the square.
I'm just giving an example. It is also a function. It is a subcategory. An equation is anything that has an equal sign. But a function is an equation that has y and x. Do you get that? So we can always say roots and solutions. But you can only say zeros and x-intercepts when you have a function. Does that make sense? It's like saying that a square is also a rectangle, but a rectangle is not a square. It's one of those situations. If you're confused by that, let me know. You can stay back. Folks, I'm doing extra help today after school. Who's going to be there? Who's going to join Ben and Greg? Good. It's a great party. Good. Okay, 4 people, folks. 4 makes a party. So we're going to be either in that room. Greg, either that room or this room. Okay, just take a look. No, you're going to do it during your spare. After school. Okay?
So
I'm still confused about the number groupings because
Yeah, what do
I've
you?
been using this. I also checked it online.
Okay.
So it's imaginary numbers are
Oh.
separate and complex are under everything.
Okay.
So it doesn't make sense to say
Okay.
like,
Okay. Okay. I actually
'cause the
didn't
real
know that.
ones would be complex.
Okay. So let me read this. Complex numbers. A and B are real numbers, and I is the number whose square is -1. The set of real numbers and the set of imaginary are both subsets of complex numbers.
So the real ones could also be considered complex.
Can I take a picture of this?
Sure.
Like, I am not a hardcore math person, so I may be saying this incorrectly. But I'm going to go to the hardcore math teachers and be like, explain this to me. Thank you.
Okay.
Thank you. I appreciate
Can I
that.
just ask you a quick question?
Please.
Could you
Oh, wait, let me stop
supervise-
the video.